So good afternoon, everybody. My name is Thomas Weishaupt from ESMIG, the European Smart Metering Industry Group, and I'm here to introduce this webinar which tries to show the benefits of the GSMA Embedded SIM Specification for utilities. This is based on a report on this topic jointly commissioned by the GSMA, ESMIG and SIMalliance from Beecham Research. First, a few words about these organizations. The GSMA represents the interests of mobile operators worldwide, uniting nearly 800 operators with almost 300 companies in the broader mobile ecosystem, including handset and device makers, software companies, equipment providers and internet companies, as well as organizations of adjacent industry sectors. The GSMA also produces industry-leading events such as the Mobile World Congress in Barcelona, the Mobile World Congress in Shanghai, the Mobile World Congress Americas, and the Mobile 360 series of conferences. For more information, you can visit, for sure, the GSMA corporate website. ESMIG is the European voice of the smart energy solution providers. Our members provide products, information technology, and services and solutions for electricity, gas, water or heat metering, data transfer and security displays or management of energy consumption and generation at consumer premises. For more information, visit the ESMIG website, www.esmig.eu. And finally, the SIMalliance is the global non-profit industry association which simplifies aspects of hardware-based device security to drive the creation, deployment and management of secure mobile devices. The organization promotes the essential role of a dedicated tamper-resistant hardware module in delivering secure mobile applications and services across all devices that can access wireless networks. By identifying and addressing related technical issues and both clarifying and recommending existing technical standards relevant to the implementation of hardware security, the SIMalliance aims to facilitate and accelerate delivery of secure mobile applications globally. SIMalliance members represent about 88% of the global SIM card market. As such, the SIMalliance membership is responsible for delivering the most widely distributed secure application delivery platform in the world, which contains eUICC, UICC SIM cards and USIM. So you see that the three main players for the GSMA Embedded SIM Specification have teamed up to clarify the benefits of eUICC in the utility sector. And now I will introduce Alistair Wright, Utilities Lead at the GSMA, who will be presenting this webinar. Alistair, please go ahead.
Thank you, Thomas, and thank you for that introduction. And in front of you now, you can see, working from the left towards the right, you can see the evolution of the SIM card. Smaller form factors leading to the embedded universal integrated circuit card, which is an electronic component. It's physically soldered onto a PCB of the final device. So just to be clear, there's no need for a SIM card holder and there's no manual intervention at the point of use. There's no insertion of a SIM card when the device is used. In addition to the eUICC, there's also a complementary software and communication solution, and that's called the Remote SIM Provisioning System. It's a specification that's been developed in collaboration with the mobile industry and the ecosystem of suppliers over a number of years, led by the GSMA. If we could have the next slide, please, David. So just a high-level overview of what the Remote SIM Provisioning System does. As you can see in the graphics, it provides a secure means of creating, encrypting and delivering profiles and data to the eUICC device, which is a secure element, updating a new device when power-up occurs for the first time, the so-called late operator binding function, and throughout the life of the device, enabling the reading, updating, deleting activating or deactivating of profiles over the complete lifetime of the device. All done remotely over the air, no physical touch points required, and all within a secure environment for both data and communications. So the specification has been developed to answer the many use cases that occur in the different industry verticals. So, for example, no user interface is needed for a water meter, and also there's no user consent required to modify details. However, in a mobile phone device, the user consent is very, very important. So two specifications have developed, one for remote SIM provisioning for M2M devices, and one for consumer devices. And the GSMA is currently working to converge these two specifications into a single specification so that there be one universally available solution available to remotely provision the SIM profiles and data. The industry provides wide support for this initiative. As you can see, there are 80+ players illustrated on this graphic. All of them support and intend to deliver different components of that solution. And now turning to the topic of today's discussion. So the previous slides really set the scene, gave you a little bit of the history of the embedded SIM specification. And as Thomas mentioned, this is a presentation that presents the conclusions of the research, which was commissioned by ESMIG, the GSMA, and the SIMalliance, and conducted by Beecham's research. It's a follow-up to two earlier studies, a study by IDC, which identified the most important utility use case for mobile IoT technologies, and they identified 18 use cases, from which 5 are investigated in more detail in this report, and also an earlier study by Beecham Research, which looked at the benefits of the GSMA Embedded SIM specification for the auto industry. The research was conducted in a number of stages and included interviews with ESMIG, GSMA and SIMalliance members, so the broad ecosystem of supply companies, and then with a selection of utility companies as well, so to test if the benefits perceived by the industry are reflected in the utilities. And the benefits were validated and verified within those interviews, conversations with the utility companies in these 5 specific use cases. So we can move to the next slide. Thank you. So, as in all industries, utilities are evolving. Distributed generation creates new challenges. Regulations change, creating new compliance requirements. Technology evolves, often at pace. There are new IoT devices, new communication technologies, and new initiatives like the GSMA Embedded SIM specification. And some initiatives like the GSMA Embedded SIM specification present both challenges and opportunities. So to stimulate the adoption of that specification within the utilities, we commissioned this study to look at the benefits. Having undertaken the study over a period of months, we then grouped the benefits into 4 areas. Improving reliability, leading to reduced site visits, very important within the utilities. Improving trust and security, also a high priority for utilities. Reducing cost and complexity both in the supply chain and for the utilities themselves, and reduced commercial risk and increased commercial flexibility. We identified 14 different benefits. We collated them into those 4 groups, and we'll now talk through each of these topic areas. So as you can see in the slide, improving reliability and reducing site visits. The late operator subscription, this is a function of the remote SIM provisioning system. So it enables devices to be delivered to site, and on power up, they connect to the remote SIM provisioning system, where the network operator profile is updated over the air, and the devices become active with the chosen mobile network operator in that particular instance. So for a manufacturer, no need to do any shipping of SIMs, no need to make additional provisions for on-site work. Everything happens remotely over the air. It's secure, it's fast, and it's reliable. Similarly, operator change. If there was a need to change the mobile network operator, this can be done over the air by a change to the profile. No site visit required. And finally, in this category, we've got reliability. So where the eUICC enables you to remove 2 components, the SIM card itself and the SIM card holder. This also gives improved reliability, and improved reliability ultimately means reduced site visits, and site visits are a cost. Second category, improving trust and security. Low cost and risk of security breaches. So being a secure element, one of the benefits is authentication, and the mobile networks authenticate at 2 levels: the network authentication itself and the device authentication within the network. So higher security than many other solutions, and trust and confidence in the data collected. You can be sure that the data is coming from the device that you expect it from. It's carried over the air in a secure manner and delivered to you with a secure solution. The eUICC itself, it's not physically possible to remove it from the device, so that removes one risk. It's also tamper-proof. It's less vulnerable to removal or failure due to the rugged environment that it might be installed in. It's got better vibration resistance and so on. We could move to the next category. Reduce cost and complexity. So I mentioned earlier that it replaces the SIM card and the SIM card holder, reducing the bill of materials. It's a small reduction, up to $50 per device, but in volume, this can make a big difference. It has a small form factor, as illustrated on one of the earlier slides, 12 times smaller than a SIM card, so it gives you much more available space within the device to either reconfigure the design or add additional components to the available boards. The next slide, please. Reducing commercial risk. So some designs of eUICC are optimized for low power consumption. So this means that they can be used effectively in situations such as water metering and gas metering, where there is no mains power available. They have low power requirements, giving you a long battery life. Similarly, because they're a soldered component, they can be configured to be safe in hazard locations, such as typically found with gas metering and so on. And there's a follow-on benefit from that in the certification of ATEX certification and similar certifications for hazardous locations. It can be much easier and much quicker with a soldered device. Ubiquitous cellular communication, you can roll out these devices to virtually any location and be sure that you'll get good coverage from your local mobile network operator. I also mentioned earlier that there are some new low power wide area communication technologies that are being developed by the mobile industry collectively. These are called mobile IoT communication technologies, and they further increase the penetration into buildings and increase the range of cellular communication. And I'll talk a little bit more about those later. Cross-vendor interoperability, so there's no tie-in to a particular vendor here. There's a huge ecosystem supporting this technology, so you're free to change vendor should you wish to, and there's full interoperability and interworking between solutions from different vendors. Now, if we look at the use cases that were highlighted, so let me just, across the top, going from left to right, you can see that the use cases were smart metering with all the different variants under that category: electric, gas, water, heat, demand response, distributed energy resource management, home energy data management, and commercial and industrial data management. And then looking down the chart, we can see the individual benefits in their different groupings. And from the chart, it's fairly clear that most of the use cases benefit from all the individual benefits. And where they don't, it'll be typically things like low power consumption. That may not be an applicable benefit where you've got mains power available to you at all times. So demand response, for example, mains power is assumed to be present, and so on. So without spending too much time on the individual breakdown of the benefits, we can see that smart metering benefits from everything, and where there's a breakdown of the benefits, you can see that, for example, low power consumption is not applicable to electricity smart metering, but it certainly is to gas, water, and heat. The improved safety in hazardous locations, again applicable to gas and others. Certification, again, where there's a hazardous environment, very important. And everybody benefits from the ubiquitous cellular communication availability and the cross-vendor interoperability. So quite a good matrix showing that there are a range of benefits grouped into different categories, and they're applicable really across the whole of the utility supply chain. So maybe we could have the next slide. So I'm now returning to a topic that I touched on earlier, new emerging communication technologies from the mobile industry, collectively called Mobile IoT Technologies. And you can see that there are 3 different technologies shown on the screen under the umbrella of the mobile IoT. Low power wide area communication technologies. They've been developed by the mobile industry collectively in a program that's been managed and coordinated by the GSMA. The technology stack is standardized by the industry-wide 3GPP process. They've got low power consumption. They're designed for low device unit costs for the communication module. They give the benefit of deep penetration and extended coverage, and they're optimized for IoT style devices with small data transfers typically, but allow for the case where you have larger data transfers, such as when firmware updates occur or security patching is required. They provide a low to medium latency communication channel, and typically that is applicable for many of the utility use cases. At the moment, pilots are ongoing worldwide, and commercial deployments of this technology will be commencing in 2017 and onwards. So that's really just a flag to say watch this space. You'll probably see lots of information in the press around this topic, but don't think of it in isolation. Also think of it as in combination with the embedded SIM specification and how the two can be used together. So in summary, what we concluded was that using the GSMA Embedded SIM Specification with the eUICC, utilities receive a number of benefits. They receive benefits from licensed radio spectrum, which gives you scalable networks, mature standards, security, a wide ecosystem of support. There's also sustained reduced cost of total cost of ownership, greater whole life device security, and scalable, reliable, trusted connectivity. You gain high reliability, increased commercial flexibility, and simplified logistics. The benefits of the remote SIM provisioning system should not be underestimated. Completing operations over the air without a physical site visit gives terrific benefits to utilities who often have lots of remote devices over a large geographic area. Finally, there's a reduced commercial risk and the proven security features. These include tamper resistance and improved trust and confidence through improved data integrity. And we encourage utilities to explore these benefits delivered by the GSMA Embedded SIM Specification and the eUICC for their particular business and their particular use cases. The reports that have been mentioned earlier are available through the GSMA website, and if you follow the link on the next slide, it'll take you straight to the reports.